excuse, where's my red? Ah, smooth. Where's my red go? All right. Please tell me that this rings a bell. Yes, that equation you learned, what, 4 weeks ago? What I want you to do at some point, literally, photocopy this over and over and over. Because for the rest of today, and all the rest of your life, you're going to be using this equation for acid-base balance problems. So you're going to be rewriting it over and over and over. That's how you're going to practice it. So, tonight, you're going to be writing this over and over and over. But the goal of this equation is to understand what your kidneys are going to do if something happens. So, let's break this thing down. By the way, always write it this way. If you write it backwards, it'll be harder. But just write it this way. Remind me what organ dealt with CO2. Where does CO2 go to die? To my lungs. So on the left-hand side of the equation, we call this the respiratory side. Because my lungs deal with CO2 directly. Make sense? So what do you think we call this side? Where does H plus and HCO3, where do they go or where are they from? Where are they from?
The organs?
The organs. We call this the metabolic side. Meaning your cells. Okay. Yes, I know lungs have cells, they have metabolism, but the way this equation is written is breathing is on the left, non-breathing is on the right. That's literally how they did it. Right? So you have a respiratory side and a metabolic side. And then what you're going to do is use that equation to answer some questions about your patient. So here we go. Here are the two words we're going to start with. The first two words we're going to use with that equation are acidosis and alkalosis. Tell me, medical professionals, what do you think acidosis means? Too much acid in the blood. Or it can mean also too little base. Both of those would make you acidic. So acidotic. You okay with that idea? Alkalosis, sock it to me. What's that mean in English?
Too much base.
Too much base or not enough acid. Those are chemically equivalent. All right, so to understand those words, you have to tell me from weeks ago what the normal pH for a person is. So tell me the range. 7.35 to
4.5.
Very good. So these are in relation to that number, that range. So that's going to describe the person. Right? Now the problem is, you have to come up with a word to tell me why you are one or the other. Right? So let's add those words. One of the words is called respiratory. What do you think the doctor means when he says you have a respiratory cause? What does that mean in English?
You're not blowing off enough CO2.
Very good. So this also means your lungs not working correctly. So if my lungs are not working right, I have a respiratory cause that's going to change the pH of my body. So far, so good. There's another word your doctor could choose, which is called metabolic. Hey, I think I know what that means. Can you guess what metabolic means in that context? Your cells or your metabolism or non-lung. Means anywhere but your lungs. Stomach, brain, something that's not a lung. So literally, breathing or not breathing. Okay, for $50, which I don't have, so just pretend. If your doctor says, congratulations, you're in respiratory acidosis, what did the doctor just bill you for? Respiratory acidosis just said what? Some lung problem is making you become too acidic. That'd be $300. So when you're doing acid-based problems in this class and in nursing school, that's what they're doing, is they're picking what you are and then how you got there. And you have to give me both on a test. I want to hear this word and one of these words. Right? Now we're going to go to the equation. and figure out if we can tie this in. So if you are in respiratory something, which side of the equation would be the one that's wrong? Over here, because it's my respiratory side. If you have a metabolic problem, which side is it? Over here. So let's do that. Let me make you have respiratory acidosis as our sample problem. Just for an example. So this means in English, this side of the equation is wrong, and I'm becoming acidic. Can you guess from what you learned 3 or 4 weeks ago how my lungs could make me acidic? What would they do or not do?
Not breathe.
Some not breathing, smoker, whatever. And what would change on this equation on this side to make me acidic?
The ions.
Was I heard it? Right, so if I have an increase of CO2, you learned way back when that CO2 becomes an acid. So if my CO2 goes up because my lungs are shot, I'm going to become acidic because my lungs are wrong. This side of the equation. Does everyone follow the logic? So now we have to add another column over here. This is the fun one. The compensation column, which means how you're going to fix this problem. Unless you want to die, you have to fix this. So I'm going to give you the wording. One of the ways you can respond is what they call respiratory compensation. What organ do you think is fixing the problem if it's respiratory compensation? That's your lungs, same as before. So I can use my lungs to try to fix the levels. Or, option 2, is urinary, sometimes called renal compensation. What organ do you think that is? That's my kidneys. Now let's think about it for a second. Why would kidneys be able to fix this problem, or a problem like that? Anyone see something that I probably erased? What was something that you secreted here? Hydrogen, which is what? So you get the idea that my kidneys can get rid of acids as well. And by doing that, they can be used to fix an acid problem. Make sense? So I can either breathe or I can pee. Those are my two choices. So if we go back over here. If my lungs are broken, so I'm becoming acidic over here, what part of my body could fix it? So the rule is you draw an arrow to the opposite side of the equation. I'm going to take it from my lungs, which are not working. I'm going to take my CO2 and put it where? Here. So I'm going to have urinary compensation. I'm going to pee the acid out because my lungs are not breathing it out. Therefore, I have to pee my answer. Makes sense? So I have respiratory acidosis, which will lead to urinary compensation or renal compensation. The opposite side of the equation. So I'm going to take the CO2 from here. I'm basically going to make it become an H, which my body can urinate. Makes sense? So what you're going to be doing on these acid-based problems is figuring out which side of the equation is wrong, then use the opposite side to fix it. All right? Let's do that. Yes?
How do you rewrite the equation?
No, you don't rewrite it. You just understand it. Correct. So let's do that. I'm going to give you something. Let's discuss. Okay, I'm going to do another acidosis. They're easy. I'm going to give you metabolic acidosis. Tell me, class, what part of the body is broken to give me metabolic acidosis?
Not your lungs.
Not my lungs. That's the best answer I've heard tonight. Yes. Something that's not my lung. My brain, my stomach, my butt. Something. This is over here. So over here, what chemical would be wrong to give me acidosis? What would you expect to see? What do you think? Yeah. Probably the easiest answer would be the increase of H+. Something is making me have more H's. You buy that? That make me acidosis. So this side is metabolic, that's acid. How would I fix that, say ye? I'm going to go over and use my lungs. I'm going to take the acid from here and send it to my lungs. where you're going to blow off the CO2. So I'm going to have respiratory compensation for metabolic acidosis. Make sense? Now we're going to add one more hard concept here, and that is the shift direction. Not shift, that's different. Shift. You have to know the shifts. What you're doing is you're saying the direction the acids move, essentially, on the equation. So in this picture that I just drew, I drew an arrow for a reason. I'm taking the acid from my body. I'm sending the acid where? To my lungs. What direction did I just go? I went from over there to over here, which is to the left. So this is a left shift. So I have metabolic acidosis with respiratory compensation with a left shift. Meaning I took the acid from my body, sent it to my lungs to blow it away. Make sense? So you have to keep track of the problem, the solution, and which way you sent the acid. All four of those things you have to kind of have work. Right? So I'm going to keep this equation up here. Write it about 4 more times in your notes because we're going to use it over and over for the next hour. But, yes.
So, is it just tradition that's written with the CO2 and H2O on the left?
Yes.
Okay.
Yeah. I mean, you can argue anything you want, but that's just the way you do it. Right? So don't mess with doctors. That's just the way you do it. All right. So what we're going to do is go back to our animations for a while and work out this acid-base shifty stuff, which is not that one. Just a second. Long one. Say hello to Patrick O'Shea. Way to go, Patrick. Your Marlboros are still on the bench. Way to go. Got that. All right. Let's look at what the doctor has announced about Patrick. We're not looking at his emphysema. That's not what I'm asking. I'm asking for his acid-base problem, which is in the bold print right here. What's he have?
Respiratory acid.
Let's break that down. Why is it respiratory?
Because he
His
damaged the
lungs are
lung
junk,
tissue.
right? You're a smoker, you're going to die. Okay, got that one. Why is he in acidosis? Can't blow off his CO2. So doctor would say your lung problem, respiratory, is making you become acidic acidosis. You okay? That's the answer you give on a test, and I need both words. Now we have to figure out on the equation what's going to happen and why. So before we see the answers, let's figure it out long way. Go to your equation again. Always draw the equation. Every time. Help me out. Which part of this equation would represent Patrick? Over here, right? What over here would be different?
The increase.
All right. So if you have respiratory acidosis, his CO2 levels would be going up, right? It's about blowing them away. Now you got to tell me the compensation. How would he compensate for that, CE? I'm going to use metabolic compensation. I'm going to pee my waste away. So I'm going to use metabolic compensation for my respiratory acidosis. So which way is the equation going to shift to do that?
Right.
Very good. I'm going to take the CO2 from here and send it to my P as an H+. So I have a right shift on the equation. Make sense? Precisely a perfect answer. So respiratory acidosis with metabolic compensation with a right shift. Sounds impressive, doesn't it? I think so. Right? So let's go to the little quiz here. How will your body compensate for respiratory acidosis? Tell me which of these would best represent the answer you've already given me. Well, why not the hyper stuff?
Because you can't breathe.
Yeah, you're a smoker, right? Your lungs. So the thing you want to think about is your lungs are always the preference. They're fast or quick. If you're a smoker, your lungs don't work. So I can't breathe, I have to pee instead. So my kidneys have to come on board. Which of those would represent what Patrick would do? Yes?
Would the body attempt to do both anyway?
Yes. But if your lungs are shot, it can't do the one, so it has to do the other one. However, if you're a smoker with bad kidneys, you die. Okay. So, tell me which ones it was again?
Kidneys excrete acid.
Excrete or secrete, because they don't pump. So I flush the acid, and I could also do something else. I could keep the base. I could reabsorb or retain base, because if I add base, I'm less acidic. So my kidneys would pee more acid, keep more base to pee the acid out because my lungs are not. Okay? There you go, Patrick. You understand that logic?
So instead of metabolic compensation there, could we say renal compensation?
Yeah, you don't, even though it's metabolic, you don't say metabolic, you say renal or
Right.
urinary. It's a metabolic problem, but you always say renal compensation. Make sense, the logic there? For every one of these problems, you're going to do the same thing. Figure out the cause, figure out the equation, figure out the compensation, and then the shifts. They're all the same math, every stinking time.
But you reference generally metabolic compensation, but
Yes.
it needs to be specific, which metabolic,
You say urinary.
urinary,
Urinary is
or renal.
renal and urine, yep.
That's the only option.
Yep, because that's the only place you can put acid. You can't put it anywhere but your breath or your pee. There's no other place to do it. So here's Susan. Sally, sorry, Sally. So she's starting to breathe really fast because she's nervous and scared of the dentist. So let's look at what the little sign up top saying. She is now in what? Okay, let's work through it. Why is it respiratory? Because she breathed too fast, right? It's a lung problem. Why is she alcoholic? I love that picture. Yeah, seizure coming down. All right. Why is she alcoholic?
Because she's breathing off too much.
Breathing off CO2. Remember what we learned? You blow off CO2. So she breathed too fast. Her CO2 went away. Therefore, she's less acidic. Right? So before we do this, let's go to our equation. And let's figure out what Sally was doing. So, tell me, Yi, what side of the equation's wrong? Left side, respiratory side. How is it wrong?
Decrease CO2.
Decrease CO2 because you just blew it all at the dentist. Okay? So what side would fix this? Urinary renal compensation, right? So I'm going to have renal compensation. Now, the shift. It's not to the right. So that means it's to the left, right? Let's figure it out. I don't have enough CO2 in my body, so I don't have enough acid at my lungs. Where can I go to get more acid? I can take the acid out of my urine and use it to make more CO2 over here. So I'm going to take acid from my urine, put it back into my blood for more CO2. So I have a left shift. So I have renal compensation, but I'm retaining the acid. Therefore, I'm shifting the acid to the left. So there's always different shifts. Don't memorize right shift, left shift. Think through it. I'm going to take the acid from my pee, put it back to my lungs. So it's going left, but my kidneys are still the ones doing that. Right? So the right-hand side of the equation is fixing it by sending stuff to the left. So again, you want to do it step by step. So on this picture here, respiratory alkalosis, my equation will shift to the left. I'm going to take stuff from my urine to fix the hole in my breathing, quote, quote. Lavoisier's principle. Right? So let's do some more of those. Let's do Jose. Here's Jose. Go for it, Jose. Should we do that again? There he goes! All right, he just threw up, right? Look at the big words. Explain to me why that was metabolic alkalosis. He's puking out. That's not breathing, right? Last time I checked, so it's metabolic. But why is the alkalosis? The stomach acid is leaving his body. He's losing acid. Remember what you learned is the acid made from your blood. So I'm losing acid from my body. It's on the floor. It's not in me. Therefore, I'm less acidic when I throw up. Does that make sense? Right? So my throwing up, metabolism, diet, stomach, whatever you want to call it, is making me less acidic. So we're going to go to our equation that you're going to photocopy and write over and over and over. So he's in metabolic alkalosis. Which side and what's wrong with it? The right side's wrong. How is it wrong?
Decrease.
I've decreased H's, or another way to view it is I could have too much H2O3. Those are both the same. But I've decreased H's, right? Because they're on the floor. Okay, smarties. How would I compensate for metabolic something or other? I'm going to use respiratory compensation. I'm going to use my lungs to fix this problem because they're quick and fast, which is the same thing. How would my lungs solve this problem for me? Well, how would they do that? How could my lungs make more acid? And how do I do that? I'm going to breathe less. or slower. So my pons will tell my lungs, breathe less. So CO2 would climb, right? And I'm going to use that CO2 to make more acid here. So what kind of shift did I just do? A shift to the right. My lung is going to slow down and send the acid to my kidneys, or to my metabolism, or my blood, whatever you're going to call it. So I have metabolic alkalosis with respiratory compensation with the right shift. Make sense? So I'm going to breathe less. Next time you're throwing up, look at your breathing rate, which I'm sure all of you are going to do while you're throwing up. You're breathing out with slow to try to get more acid to refill this. Okay? All right. So you get the idea. It's always the same mechanics. Use the equation, figure out what's where. That's always the same. So if you're catching on to that, I think you are, let's do a little quiz. The acid-base game. Here we go. Here is Dan. Dan had diarrhea. So first thing it asks us is pH going to go up or down?
Down. Down.
Will it become more acidic?
I'm sure you've never checked the pH of your poop. Am I the only one? No, I'm sorry, a friend who's the only one. Okay. So go back to that chart you did in the digestive system. What was the pH of your intestines? Basic. So I'm losing base, right? So therefore I'm going to become more acidic. So if I poop, I'm going to become acidic. Yeah.
But wouldn't you lose a lot of water in the process?
Yes. But that won't affect the pH per se. You're going to lose the buffer with it. So if I become more acidic, my pH levels will go down. Right? So let's now figure out what he has. So I've figured out he's acidic, so we know he's acidosis, right? Now we got to figure out which one. Well, hold on. So this is asking about the HCO3 level first. Let's go to our equation. What side is HCO3 on? They're asking about this. So, if I am doing that, what will my HCO3 do if you think I'm becoming more acidic? HCO3 should be going down. Because if I'm gaining acid, it's like losing a base. So, will it go up or down? I think it'll go down. Very good. So now, we pieced it together that his pH is getting acidic. He's lost something on the right-hand side of the equation. Therefore, he is officially in which of the four choices?
Metabolic.
Metabolic, what?
Acidosis.
Acidosis. His diarrhea is making him more acidic. Diarrhea is metabolism. Sure isn't breathing, I hope. Acidosis. So now, he has to compensate. Which of the two choices will he do if he's in metabolic something? He's going to use his lungs preferentially. So he's going to have respiratory compensation for metabolic acidosis. Okay? Or on the equation, if you didn't like that, his problem's over on the right. He has to use his left-hand side to fix it. All right? So, let's do number 2. This should be Martin. Here's Martin, who didn't wear his helmet. Now he's messed up. So his pons is telling him to breathe too fast. So what will happen to his pH if I breathe too fast? Maybe just put that in big final. We breathe too fast. If I breathe too fast, I blow off more acid, which means my pH becomes less acidic, which is
Basic.
a higher number, basic, right? That's 112 again. So now it's asking about the CO2, which is on the respiratory side. So if I'm Martin, I'm breathing too fast, my CO2 level should be going down because I'm blowing it away, right? So now we have to piece it together. So what problem does Martin have?
Metabolic, right? No, respiratory. Alkalosis.
Very good. His breathing is making him less acidic, so respiratory alkalosis. Therefore, what system would fix this problem, say ye? He's going to pee or urinate or renal compensation. It's the other side of the equation. Make sense? Yes, Ed.
What happens if you're puking and diarrhea?
If they're equal amounts, you'll actually stay neutral. You'll stay neutral. Yeah. You'll have electrolyte problems to no end, but your pH will stay fine. Yeah. If you wonder why your nerves get tingly after vomiting or the flu, it's because you start screwing up your acidity. Nerves are very sensitive to that. So your brain starts to misfire. So you get tingles and carpal tunnel spasms and all that. Yeah.
I
So
have
your
a,
body will try its best to keep this normal. But
I have a question. So with colonics, I know
Yeah.
that's really gruesome, but
yeah.
why do people use copy colonics?
Because they like to kill themselves. I don't do anything. Colonics don't do anything. I'm not sure why people do it at all.
Interesting.
Nope. Scientific research says it does absolutely zero except make you dehydrated and puncture your colon. I don't know why anyone would do that. Yeah.
There's
Copy-
spas who do it around
Oh yeah, 'cause you
there.
pay money, right?
Yeah.
That's fine. So yeah, there's no research that suggests colonics do anything except just spend your money.
Got it.
So doing okay on this logic? So again, use the equation, find your way through. Now we're gonna make it harder for you. Because PCC says thou shalt know the normal values of these. So you have to know the values because on a test, I'm not going to tell you which one it is. I'm going to have you try to calculate it. So let's go through it. Remind me again the normal pH values for a human being.
3545.
7.35 to 7.45. Thou shalt know, right?
Yes.
You're supposed to know the normal values for CO2 and the normal values for HCO3-. The problem is, depending on where you look and who you talk to, these numbers fudge a little bit. So I'm going to give you a range that works for our class. CO2 is normally somewhere around 30 to 35. It can be up to 40, but usually it's not much higher than that. You'll see people say 38, you'll see people say 41. 35 is a good number, yes.
What's the unit there? Millimeters?
Millimeters mercury, or PO2s. HCO3, you'll see a range. Usually, most people will agree to that range. Again, Saladin, I think, quotes 21 to 26. Wikipedia says something about 23 to 29. So what I do in my head is I pick one number in the range. 7.4, about 32, about 25. And that's how I keep it in my head. And then I just realize that as you get further away from that, you're more abnormal. Everyone with me? So you should know these values on a test, because I'm going to use them. So we're going to use them here. Right? Again, different people will argue different numbers, but just for today.
Is the HCO3 also millimeters of mercury?
No, it's actually milliequivalents per something or other.
Okay, so we don't need.
Just know the number. Yeah. So here we have Clarissa. So we're going to check her pH. 7.5. Tell me, future nurses, what does that mean? I thought 7 was neutral in 112. For water, not for us, right? So we're using that number. It's higher than 7.45. Therefore, it's more basic than normal. Therefore, the word we're going to pick for her is? She's an alkalosis. You made me $100. So the first thing you do is the pH and get the first word. Now we have to check the value. So they want me to click HCO3. 30. Is that really high? Yeah, because 20 is where it should be. Is that equivalent, consistent, reasonable if you're alkalotic? Because HCO3 would be high.
Yes, too much.
Yes, because that's a base. I have too much base. That would make me basic. Duh. So now we have to figure out what she has. So you're going to go to your equation, and you're going to say, okay, what side of the equation has HCO3 on it? Therefore, tell me which of these four, for $100, does she have? You know, if you click the wrong one, I lose $100. I get very mad. I have 3 kids in my life. Come on. Which one is it? Future nurses? Metabolic alkalosis. Right? Higher pH than normal, metabolism sides off. She drank baking soda. So she ate something basic. Right? So now, she's going to fix this problem before she dies. Look at these choices. Tell me the compensation you will see.
Too fast. She took an antacid, right?
Breathe slower to increase
I hope I don't ruin your hospitals. Okay, let's go through it. She's in metabolic alkalosis. So if we do our math on our equation, she has too much of this, right? which is the equivalent of saying she has too little of this. She's going to have to get something from over here. So she's going to have to take CO2 from her lungs and use it to make more acid in her body, right? How do I get more CO2 in my lungs? I have to breathe slower. So she's going to try becoming acidic at her lungs to make her body acidic. Therefore, she's going to breathe slower. Respiratory compensation with the right shift. Make sense there? Very good. Here's Mary Ann. Come on down. Not Jillian. 7.28. The magic word you're going to say is acidosis for a person that's really acidic. Now it asks us to check the CO2 button. Tell me. Is that high? Yeah, because 30s. I mean, they say 35 to 45. I'd say 35 to 40. I mean, you get it about 35 is the number most people can agree on. Is that consistent with being acidotic?
Yes.
Yes. So now, give me the big words.
Respiratory acidosis.
Respiratory acidosis. You're acidic because CO2 is wrong. Tell me how she's going to fix this for $100.
So,
What system am I going to use to fix the respiratory problem? Okay, so now you got to figure out what my urine will do.
Acid.
See, if I'm acidic, I want to get rid of it, right? So we have to excrete acid, or H+, and then I can also keep or reabsorb, retain base. Although she died already. All right. You okay with that logic? So again, every one of these acid-base problems is the same. You figure out what the person has, what side would compensate, how you'd compensate for that side. Make sense? Okay. Sketch packet of doom. Our last exercise for tonight. Find page 28. We're going to practice this a little more. I beat you up. We're going to skip to case number 2. We're going to do this as a class. In the back of page 29. 30. Sorry. This one. So 29, I think it is. Erase those. Erase that. So what we're going to do, we're going to do this case thing as a class, again, to walk you through the logic of this. But they're always the same. So hint, hint, always write the equation every time you see acid-base. Just write it. Then you're off and running. So I'm not even going to read about the girl. I'm going to jump right to these numbers I told you to memorize. pH of 7.3. Give me the word to say that. She's acidic, so she's in acidosis because 7.3 is below 7.35. So we have half the answer I'd want on a test. So now we got to figure out why. So we're going to look at the CO2 and the HCO3. The other one's really irrelevant. You're looking at those two. Take a look at those. Tell me which one of those values is the wrong one. You sure? Yes, because what's the normal value for HCO3 is in the 20s. That's cool. The CO2 should stop in the 30, maybe 40. It's way, way up there. So on my equation, that's going to help me out. This side is wrong. So what word am I going to put in front of acidosis? Congratulations. Question number 1. When it says acid-base status, you give me both of those words. She's in respiratory acidosis. With me? Because this number is high. So we're going to skip down and try to figure out how she's going to compensate. Before we read the questions, we're going to try to figure out the rest of it. So, if she's in respiratory acidosis, what compensation will she have? She's going to use urinary compensation or renal compensation. We'll put renal, just to give something different. Hence on question 3, it asks about the kidneys. renal compensation. Now you gotta tell me how her kidneys will compensate. So let's think about it. I have too much acid at my lungs. I have to get rid of it. So I'm going to take the acid from my lungs, and I'm going to draw an arrow. I'm going to send it to here, and turn it into H+. And then what's my kidney going to do with the H+? Excrete. So I'm going to excrete or secrete the H+, and I'd probably, just for laughs, retain the buffer. Or you could say a right shift. I'm taking the acid and sending it to the right-hand side of the equation. So my respiratory acidosis has renal compensation with a right shift, or excrete acid, retain base, renally. Make sense? That's the logic. So I don't even have to read the rest of it. I know the answers to the acid base, what's wrong, and how to fix it. Then if you go back, then you can try to see if that makes sense. So she has cystic fibrosis, you learned in 112, is when your lungs ball up with crud, right? So my lungs are bad, I'm going to have a respiratory problem. Therefore, I have to use my kidneys to pee the acid out because my lungs are broken. Make sense? So that's the logic behind it. So we're going to skip those rest of those questions. We're going to go down to the next one. Your job with your team, I'm going to give you roughly 1 minute to figure out case number 3. What's wrong with her? How would you compensate? Go. You're in the ER. You have 1 minute to save this person's life.
So she's more alkalosis, but she's vomiting.
She's losing oxygen in her stomach. Or alcohol.
So she would need more CO2, so she would need
Patient's going to code in
a
30
right shift,
seconds.
right? Metabolic alkalosis.
So her hydrogen's down. She's having a difficult time. It'd be metabolic alkalosis. Is that what you said?
Uh-huh. That's what I think.
And then, okay, and then why might excessive vomiting cause her particular
5 seconds.
Because you're
Oh my goodness.
ejecting the hydrogen. How would the kidneys compensate for the acid-base balance? It would retain base. No, it wouldn't. It would excrete. It would excrete the bases and retain the hydrogen. Sorry.